Hello everyone and welcome back to another video. Today we're going to be talking about S1 statistics, otherwise known as our measures of central tendency outcome, as well as the S2 percentiles outcome. When we talk about statistics, I often get an eye roll from most of my close friends because, admittedly, for a lot of people, statistics can be boring. Now, the aim of this lesson is to take out some of those misconceptions about statistics and give you a better insight as to the type of information that statistics can provide us. Statistics has the value of allowing us to inform people about past trends, as well as make predictions about trends that are coming up in the future. Something that statistics also does, or rather the ability to interpret statistics, it allows us to interpret information that's being given to us and allow us to form our own opinions about the information that we see or hear. A really good example of that is if I were to state that 50% of a class failed an exam given by a teacher. Now, given that statistic of 50%, you might say, well, maybe it was a really hard exam. Maybe the teacher didn't do a very good job of teaching the content. Well, there's more of a story to that, or there could be more of a story. What if I now told you that there were only 2 students in the class and 50% of those students failed? Well, now in this case, 50% of 2 students is just 1. So 1 out of 2 students failing is actually not that bad when you think about it in that particular sample size. Now, again, we just need to take statistics with a grain of salt, but hopefully what this outcome allows you to do is to be able to interpret and make your own judgment on the type of information that you are receiving. Now, to start us off, let's talk about our first definition, which is a measure of central tendency, which is really just a fancy way of telling us about a number that a data set is clustering around. So if I were to give you a whole bunch of numbers, say, for example, 10, 11, 12, 13, then we could say that that set of numbers roughly clusters around 11 and 12. We wouldn't say that it clustered around 20 because, well, it doesn't. Now, there's a number of different definitions and terms that we associate with these measures of central tendency. And one of those types of measures is what we call the arithmetic mean, more colloquially known as our average. Now, typically in statistics, we use the symbol X bar, which is really just an X with a line over top, to represent the average of a set of numbers. Now, as some of you might already know, we can calculate the average of a set of numbers by adding up all of the numbers in the set, and then we're just going to divide it by the number of values contained in that set. So just as an aside here, so we can put that into a nice fancy formula, we can say that the average, or the mean, we can say X bar, is equal to the sum of values divided by the total number of values. So we'll take a look and see what that means in this first example. If we look at the set of numbers 3, 5, 8, and 12, if we wanted to find the average, we would first add up all the numbers. So 3 plus 5 plus 8 plus 12 gives us 28. And then after that, we're going to divide the total by the number of values in the set. And there's going to be 4 values because we have 4 pieces of data. So 28 divided by 4 gives us 7. So therefore, the mean of this set, or the average of this set, happens to be 7. We can use a couple of examples to help us out, or to further our understanding. If you want to calculate the mean of each set of numbers, we can round to the nearest tenth here. We've got 19, 28, 49, and 85. Let's go ahead and let's add those all up on our calculators. And we're going to get a total. If we add those 4 numbers up, or these 4 numbers, we're going to get a total of 181. So 181. And we're going to divide that by our total number of values. So we have 4 in this case. So 181 divided by 4 gives us about 45.25. So let's just say 45.3. If we look at our second example, we've got 123, 238, and 473. If we add those all up, we get a total of 834. And if we divide that by the number, or the total number of values, we have 3. So 834 divided by 3 gives us 278 on the dot. So 278. I know we said round to the nearest tenth. In this case, it's a whole number. We won't worry too much about that. And last but not least, we have a couple of examples with some negative integers. So that's okay. We're still going to add them up like usual. -3 plus 0 plus a -10 plus 4 plus 12. And we get a total of 3. Now we're going to divide that by the total number of values. So we have 5 numbers there. And we get 0.6 is our mean or our average of each of this particular set. Let's try out a quick word example. The Toronto Raptors scored 83, 124, 98, 5, and 107 points. Did I say 5? Did not mean to say 5. So in this next example, it says the Toronto Raptors scored 83, 124, 98, 102, and 107 points in its last 5 games. What was their mean score per game? Our first thing that we need to do is look for the sum. So the total of our values. So the total is equal to 83 plus 124 plus 98 plus 102 plus 107. Let's go ahead, punch that into the calculator. So we end up with a total of 514 points. And we have 5 games. So we're going to take 514 and divide that by 5. And we get about 102.8, which is really 103 points is their total. So 103 points was their average score per game over their last 5 games. So the next few questions I'm going to get you guys to work through on your own. Again, that's going to be available in your handouts from D2L. Let's take a look at question number 5 here. Jason received marks of 75, 92, and 83, and 86 on his last few science quizzes. If he wants his average mark to be at least 86% overall after his next quiz, what mark will he need to get? So just in case we're curious about his current average, if we take all those marks, 75 plus 92 plus 83 plus 86, we get a total of 336, and we're going to divide that by 4, and we have an 84% average, very respectable. So he wants to improve that average by another 2%. So what we need to do is we're going to focus on our formula from earlier. We know that our average, x bar, is equal to our sum of all values divided by the total number of values. So let's take a look at each individual piece here. We know that his average that he wants is going to be 86, so that we can call that our x bar. He's going to look for his average after his next quiz. So taking into consideration that we have 1, 2, 3, 4, plus one more quiz, his total number of values is going to have to be 5. Now the sum of all values, let's go ahead and rewrite this down here. Oops. So we're going to have 86 is equal to something divided by 5. So in this case, we're going to go ahead and add up the sum, or total up the sum of all values. 75 plus 92 plus 83 plus, and let's get rid of this here, plus 86. Now we say after his next quiz. We don't know the mark from his next quiz yet. And typically in math, if we don't know the value of something, we're just going to assign it a variable. Let's just call it x in this case. So really we're just left with an algebraic equation where we're going to solve for x. So our first step here is we're going to take that 86 and we're going to multiply it by 5 because we need to get rid of that denominator on the bottom. So we're going to multiply everything by 5 on both sides. We'll end up with 430 is equal to, and let's quickly add up that total, 75 plus 92 plus 83 plus 86. We said that was 336 plus x. We're going to subtract 336 from both the left and the right-hand side. And we end up with 94 is equal to x. So this means for us that our friend Jason here, he will need 94% on his next quiz if he wants to reach that 86% overall as his average grade. Again, I've left some examples for you guys to work through, or one more example for you guys to work through. And then we're going to talk about another measure of central tendency called the median. So the median, and I'm actually going to get rid of that pink there. So the median is really just the middle number in a set of data. Now we have to consider, once we've ordered our set of values from least to greatest, we want to consider what happens if we have an odd number of values versus an even number. An odd number is fairly straightforward. Let's say, for example, if we have 3 numbers, that second number will be our median. If we have 5 numbers, that third number from least to greatest will be our median, and so on. Now, in the case of having an even number of values, let's say, for example, 3, 7, 9, and 12, we're going to take an average of the 2 middle numbers. So for us, because we've already labeled this or reordered this from least to greatest, 7 and 9 happen to be our 2 middle numbers. We can take the average of those, which is 7 plus 9 is 16, and divide that by 2, which gives us 8. Or we can just see that the number 8 fits nice and clean in between those. So 7, 8, and then 9. So our median in this case happens to be 8. Our last of our 3 most common measures of central tendency is what we call the mode. Now the mode is the number that appears the most in a set of numbers. We can have 0, 1, or multiple modes in a set of data. So for example, referring back to our previous example of 3, 7, 9, and 12, there is no mode because no number appears more than once. We wouldn't say that we have multiple modes in this case because we don't. All right, so let's go through a quick example here, 7a. If we want to find the median and mode in this set of numbers, we want to go ahead and reorder these from least to greatest. So let's go ahead and do that quickly. All right, so after we've done all of that, we can see that we have 15 numbers reordered from least to greatest. So if we're looking at the median here, remember that's going to be the middle number. Since we have 15 numbers, we're going to look for the one smack dab in the middle. So we're going to look for number 8 in order. So we got 1, 2, and maybe I'll use my mouse here. 1, 2, 3, 4, 5, 6, 7, 8. So our middle number is the one in the 8th position. That is going to be our median. And then for the mode, remember the mode is the number that shows up the most often. In this case, it's going to be 45 because let's see. We've got 45 show up 3 times. So 45 happens to be our mode in this example. Again, I've left you guys some extra practice questions to try out, so please go ahead and work through those on your own. So we're going to move on ahead here to a slightly different concept, but still very related. With a quick example, we can look at a few houses in a neighborhood, and we find that their individual values or prices were $250,000, $580,000, $600,000, and $670,000, we can calculate the arithmetic means, or the average, to be $390,000. Now, can you guys see any issues with announcing this as the average price of a house in that neighborhood? Well, there are a couple. First of all, it's a little bit misleading. 400,000 doesn't necessarily convey the best picture. In this case, 400,000 is about $150,000 more than the lowest valued house. Now, the next three houses there, 580, 600, and $670,000 houses, those are valued at far more than $400,000. So that $400,000 or $390,000 is mathematically, yes, it is the average, but it doesn't necessarily give us the best representation, the most accurate representation of a set of values. So we can mitigate the impact of any of those values that are quite different, whether by being larger or by being much smaller than other values in the set, by using something called the trimmed mean. So what a trimmed mean does is it will disregard any outliers, otherwise known as values that are much larger or smaller than all the other values, when calculating the mean. So essentially, if we were to redo this first example, this quick example here, we would actually take out that $250,000 house, and we can figure out that the average house in this neighborhood is about $616,000, which paints a much more accurate picture of the types of houses you would find in that neighborhood. So we can go ahead and work through another example here together. A data set contains the following values: 3, 9, 5, 8, 4, 6, and 20. We're going to go ahead and calculate the arithmetic mean. So we're going to go and add those numbers up. So 3 plus 9 plus 5 plus 8 plus 4 plus 6 plus 20. That gives us a grand total of 55. So we got 55 divided by the total number of values. In this case, we happen to have 7. So 55 divided by 7 happens to be about 7.85. Let's just say 7.9. And we're going to figure out if there's any outliers. So an outlier is going to be something that's way above or way below everything else in the data set. In this case, it's very apparent that it happens to be 20. So we're going to go ahead and redo everything. So in this case, we've got 3 plus 9 plus 5 plus 8 plus 4 plus 6. And that's going to be equal to 35. And we're going to take 35 divided by, in this case, 6. And we now get an answer of 5.83 repeating, and let's just say 5.8. Now, what is the difference between the arithmetic mean and the trimmed mean? So this includes, or the arithmetic mean includes every value. And on the other hand, the trimmed mean, it does not include outliers. Or we can say it does not include extremely large or small values compared to other data points. Let's take a look at question number 15. Calgary, Alberta is known for its Chinook winds, which are just warm winds that blow from the Pacific Ocean and can raise the temperature significantly over a short period of time. The following table shows the daily high temperatures for 1 week in January, during which there was a Chinook wind. Now, living in Calgary over the last 4 years and Edmonton for the remainder of my life, I could probably say that a lot of these can be quite warm. We've had a few fairly warm winters recently. So if we take a look here, we've got -12, -14, -5, 15, -8, -10, and -12. So if we're looking for the mean or the average high temperature for the week, all we need to do is go ahead and add all those values together. So we've got -12 plus -14 plus -5 plus 15 plus -8 plus -10 and plus negative 12. And that gives us a grand total of negative 46. So we're going to take the negative 46 and we're going to divide that by 7 because we have 7 days of the week. And we get a grand total of negative 6.6, roughly negative 6.57 to be more precise. So let's just take negative 6.6. On what day did the Chinook occur? So we're going to look on the day where we had basically an outlier where it was much warmer than all the other days. And we can see here that it's going to be Wednesday. So if we look at the trimmed mean, basically what we're going to do is we're going to get rid of one of the data values. So in this case, we're going to get rid of the Wednesday value. So we're going to basically get rid of that plus 15 there. So let's go ahead and recalculate that. So negative 12, negative 14, negative 5, negative 8, negative 10, and negative 12. So we get negative 61 in this case is our total of those values. And we're going to divide that now by 6. So if we divide that by 6, we get roughly negative 10.16 repeating. Let's just say negative 10.2 degrees Celsius. And let's just add that unit to the previous answer, which is the better indicator of the expected daily high in Calgary for a week of January. Why? Now, for those of you who say, well, why isn't it accurate to record the arithmetic mean, right? If we're just looking at our first answer, negative 6.6, well, we can see a couple of different reasons. Negative 6.6 would place that as the the third warmest temperature. It's only bested by the negative 5 and the plus 15 here. Every other temperature here in the week is much colder than that negative 6.6 or the minus 6.6 degrees Celsius. Now, because we've taken out this outlier of 15 or plus 15, it gives us a more realistic picture of what life is like living in Calgary in the middle of January, which is, minus 10 degrees Celsius. It's not that bad, I promise you. Come visit. It's great. You have the Rockies, you have Banff, you have lots of things to do. But minus 10 is a much better indicator because it accounts for the fact that we are taking out kind of a random occurrence in the Chinook, and we're giving you a better and more accurate picture of what the daily high in Calgary would be for a week in January. Now, I do want to emphasize the idea that the interpretation of the numbers that you're looking at is quite a bit more significant than the actual calculation of each number. So, for example, the most recent question that we did about which one's the better indicator, or for example, if we take a look at this list of commuting times in the next question, if we wanted to look at this question, which asked, what could affect the commuting time? So we can see here that some of the most obvious outliers, we could see one that we have here as maybe 30 minutes to commute versus a 75-minute commute. Everything else is roughly between 40 to 50, 51 minutes long. So there's maybe a 10-minute span where this person's typical commute, Rashid, where Rashid commutes to work. Typically, it's within this 40 to 50 minutes is his average commuting time. Now, a question like this where it asks what could affect the commuting times, I do want you guys to think about things such as traffic jams, or maybe even a lack of traffic jams for him to get to work in 30 minutes. Or maybe there was a public holiday where most people were not working that day. Or maybe there was just a certain rush because everyone's trying to get in and out of the city during that particular day, which could have resulted in a traffic jam. There might have been construction delays. Maybe there is a train that broke down and was blocking the road. There are so many different things that you guys need to be able to think of and to be aware of how those affect things like averages. Now, the last thing that we're going to talk about in statistics is what we call the weighted mean. Now, the weighted mean is something that is used quite often, especially in school, for us to calculate when certain data values are worth more than others. So the example that we have here, a teacher might take quizzes as 50% of the grade, assignments are worth 20%, and the final exam is worth the remaining 30%. So this is why sometimes if you guys do an assignment where you get 100%, it might not change your mark quite as much as some sort of quiz where you only received 60% as your grade. So things might not change the needle as much as you think it does just because of the way that things are weighted. Much like, for example, if you were to buy a brand new car, you would consider things such as perhaps the number of seats it has, or the horsepower, or the color of the car, or the model or the brand of the car to be much more important than if the car has, for example, a turbocharged engine, or if it's an i4 or a V6. So some things you definitely weigh or consider a little bit more than others when it comes to making some sort of opinion or judgment. Now, looking at this first example, Frida earned grades of 85%, 72%, 65%, and 90% on 4 tests in one term in her math class. If each test were worth the same percentage of her final grade, what would be her final grade? So all we need to do in this case is we are going to total up the sum of all 4 grades. So let's go ahead and add 85 plus 72 plus 65 plus 90 gives us a total of 312. And we're going to divide that by the 4 tests. So they're roughly worth 25% each. So once we divide that by 4, and we get 78%. So that would be her final grade. Now, that's probably the simplest way to calculate a grade, but of course, it really depends on what the weighting of those grades is. Now, we're going to recalculate her grade if the first test was worth 10%, the second test was worth, or second and third were worth 20% each, and the final test was worth 50%. So we're going to convert those percentages into decimals. So we can see that the first test, which was 85, we're going to take that 85 and we're going to multiply it by 0.1, that's 10%. And we're going to add that to having a weighting of 20% for the second and third test. So we're going to take the 72 and multiply it by 0.2. We're going to add that to another 20% weighting from the 65%. And then we're going to finally add that to our last test result, which was the 90%, which was weighted at 50%. Now, if we go ahead and plug all of those numbers in, we end up getting 8.5 plus, it takes 20% of 72 is 14.4. 20% of 65 ends up being 13. And 50% of 90 is just 45. So we're going to go ahead and add all of those marks up. And we get a grand total of 80.9%. So using a more weighted system in this particular case benefited Frida because we took such a large percentage of her grade from her final test where she did the best, and we didn't take as much from some of her poorer results with the 72 and the 65%. Now here's another question for you guys to try out, but again, usually weighted means you'll use the most often in calculating things such as school grades. Now, when it comes to the word percent, some of you guys might go running away, screaming in tears from your computer screens. That's okay. Percentiles are quite related to the word percent, meaning out of 100. Now, the biggest difference between a percent and a percentile is that when you think about a percent, it's some sort of portion out of 100. So 25 out of 100 gives us 25%, while a percentile is some sort of number that shows the percentage of values that are lower than that given value. Now, a term that is closely related to percentile is the percentile rank, and a lot of times people use percentile and percentile rank quite interchangeably. Now, percentile ranks can only range from 1 to 99, as we can't have 100% of our values be below a certain number. Now, we want to note that some textbooks or resources might state that your values are equal to or below a certain number, but for all intents and purposes in this course, we're just going to say that it's all below a given value. Now, to calculate a percentile rank, we're given the formula. Percentile rank is equal to b over n multiplied by 100, and b is going to be the number of values below the one being considered, and n is the total number of values in this data set. So let's try to calculate the percentile rank of the number 8 in this first example. So we note that the number 8 is going to be in that second position there. We're going to go ahead and use our formula. Percentile rank is equal to b over n times 100. In this case, b, which is the number of values below the one being considered, we can see there's only one number below 8. And n in this case, if we quickly go ahead and count, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. There are 10 total numbers. So we can calculate the PR as 1 over 10 multiplied by 100. And that's 0.1 times 100, which is just 10. So we can consider stating our solution in a couple different ways. We can state that the number 8 is in the 10th percentile, or it has a percentile rank of 10. Let's go ahead and take a look at another problem with a bit more context. We have some players from the senior boys volleyball team with the listed heights. We need to calculate the percentile rank of the players of the following heights. I've gone ahead and pre-wrote those out from least to greatest. So we can see here that 172 centimeters is going to be fairly close to the middle here. And again, we want to look at our formula. PR is equal to b over n times 100. We want to consider what's our value of b here. How many numbers are below the 172? So in this case, we have 6 numbers below the 72, and there are 12 players in total on the team. So PR is equal to 6 over 12 times 100. So our PR is 0.5 times 100, and our percentile rank ends up being 50. So we can state that the percentile rank is 50, or we are in the 50th percentile. Now the next one is it's a little bit trickier than it appears. 190 centimeters. Now, if we take into consideration our definition of percentile rank, we can't have 100% of the values below a given value. If we take this, we can't, by definition, have 100% of the values be below 190. So we still have to be able to calculate our percent rank. So in this case, our number of values below 190 ends up being 11. And our total number is still 12. So we have our PR is equal to 11 over 12 times 100, and 11 over 12 ends up being about 0.92 times 100. And if you go ahead and write our final number, our PR is equal to 92. So our percentile rank is 92, or we can say it is a player with the height of 190 centimeters is in the 92nd percentile. So really we're just saying that 92% of the team is shorter than 190 centimeters, which really just means that the player with the 190 centimeter height makes up the remaining 8% of the team. Now, if we're looking here where we need to work backwards a little bit, there are 64 competitors in a golf tournament. Michelle places in the 75th percentile. How many people finished with a worse result than Michelle? So we want to be able to figure out a couple different things here. We know that the percentile rank is going to be 75, and there's 64 competitors, which means that our n value is 64. So looking at our formula, PR is equal to B over N times 100. We can actually simplify this formula. PR is equal to 100B, and you'll see why I did that in a second here. PR is equal to 100B over N. And the reason why I did that is because once we substitute in our different numbers, 75 is equal to 100B, we're trying to figure out the value of B in this case. We don't know how many people finished worse than Michelle. So 100B over 64. In this particular case, if I kept my original formula, B over 64, I'd have the 64 here. It'd be tougher for me to figure out, am I dividing by 100 first? Am I dividing or multiplying by 64? Here, it's fairly clear to see that our first step needs to be multiplying everything on the left side and the right side by 64. In this situation, if we multiplied everything by 64, there would be some people who would be really confused and try to multiply the 100 here by 64 as well. And it'd really just be multiplying by 64 twice, which is really not good for our calculations. So let's go ahead and rewrite our product here. So 75 times 64 ends up being 4,800, and that's equal to 100B. We're going to divide both sides by 100, and we get 48 is equal to B. So what does that mean? What's our interpretation of that answer? It just means that 48 people finished lower than Michelle. So there are a few more questions that I'd like for you guys to take a look through as you complete the rest of this booklet, but that is it for me in this video and the rest of S2 percentiles here. Hopefully you guys enjoyed this video and lesson about statistics and percentiles. Hopefully you guys don't run away from stats. They are actually quite interesting. They do a lot to inform you about day-to-day life. If you are planning on becoming a small business owner, for example, you can figure out the average amount of money people spend at your store, the amount of time they spend browsing. All of those are important metrics that will help your business be a better business in the future. Until next time, I'll see you guys in the next video.